Hello everybody, welcome to Romi lesson 6, which has to do with the gyro. Now this is actually my favorite lesson because you basically take everything that you've learned and then you put it into one thing. So I'm not going to be able to, well, I could, but I want you to try doing this on your own first. In this video I'm just going to show you where everything is, just to remind you, and just explain what I want it to do. Because this is, I don't know, I had the most fun with this. We're using the gyro, which is basically a component inside the Romi that tells it which direction it's facing. So if it's on the ground like this, and we turn this way, it's going to tell us how far we turned and which direction we're turning in, which is really useful for keeping it on track. Because some of your Romis, when you just drive forward, they start turning. And some of them are a lot worse than others, but they just start turning and they start drifting over time. So I want to make it to where our autonomous mode corrects itself. And the gyros on the Romis are terrible, so they're going to drift. And I have found a way to correct for it just a little bit. But calibrating the gyro in the web UI helps, changing your code a little bit so it corrects itself in the code helps even more. But none of those are required. But it's really as far as you take this. So we're going to go a little bit forward here. So get gyro angle Z, I don't think it's like that anymore. I think it's, well, let's just take a look. We go to onboard IO, I believe the gyro is in here. No, gyro is in drivetrain then. Okay, here's your gyro. Romi gyro, M gyro. So if we look for M gyro, it's all the way at the bottom. There's a little bit of labeling here. So we get, it's a get gyro angle X, gets your angle X, Y, and Z. So I think, I don't know. I think this is angle Z. It could be this is angle Z. I don't really know. But you have this direction, and this direction. I don't know why you'd ever use this direction or even this direction. Maybe if you're going up a ramp, maybe for balance, like on a teeter-totter. But this is the one you're going to want to use. And I don't remember which letter it is. So that's what you're going to have to figure out. But you're going to be using your drivetrain subsystem to get, I think it's Z. You can start with Z. If it's not, it's X. But you're going to be calling this, and it's going to be returning mgyro.getAngleZ. And what I ultimately want you to do with this is create a command that corrects itself. So if it goes off course by like 10 degrees, it'll increase the speed of this wheel, bringing it back on course. Now, I think the first step that you're doing is with LEDs, and you could even print it off. I want you to do the LEDs, but I also want you to print it off into the terminal to see what angle it's currently at, just to help you debug. And you can do the system.out.println command for that. But I just want you to try that first. So if it goes off course by more than 5 degrees, I want it to turn red or something. If it's in between -5 and 5, it's green. I don't know what the exact wording is. If we go to this, okay. So yeah, have a green LED be on when the Romi is facing straight, and the red LED on when it's more than 5 degrees off straight. That's the first one. And these are fun too, because you can hold them as steering wheels and it'll move. Edit the arcade drive so Romi always faces one direction, even if you bump it or move it. That's the really fun one, because I just want it to drive forward slowly, and then if it drifts off, it'll correct itself and keep going straight, right? Or even it'll correct itself even if it's a little bit off course. So if it's off by 2 degrees, it moves maybe 2% faster on this wheel, just so it can correct. And you can adjust the numbers too. Have the Romi drive forward while the Romi auto corrects its direction if it goes off course. And this is the most fun one because you can kick it and it'll go and it'll go back on course. And it's a lot of fun to play around with it and mess with it. And if you overcompensate, it shakes back and forth, which is actually something called, this is kind of similar to PID control on the robot, and even closer to what the swerve wheels actually do. Because how does it know which direction to spin when you move the joystick? It uses encoders instead of gyros, but it's kind of the same concept. So So I want you to use some conditional statements, use some math here. There's a ton of different ways to do it, and it's a lot of fun. So if you need help with this, let me know. But after you finish this one, it's kind of up to you what you want to continue with. We'll see how far we get in the season, but if it's really early on, I might teach you how to do some of the FRC programming stuff over there, maybe some path planner and GitHub things. I'm also going to be doing, right after this one, I'm going to be doing an electronics overview lesson, which is going to be fun. So we're talking about that. We're going to do some crimping. But yeah, after you finish this one, it's really up to you what project you want to work on. But this is my favorite. So good luck. Ask me if you have any questions.